Hello guys, I'll be discussing the last question from today's weekly contest. And here's the question. Find the longest equal subarray. For that, you are given an array nums and you are also given an integer k. And what are equal subarray? Equal subarray is a subarray where all the elements are equal. And you can note that an empty subarray will also be an equal subarray. That means the minimum length of equal subarray is 0. Okay, so you can see parallelly that Ivan's answer is 0, but in my answer as well. Okay, let's read further. Return the length of longest possible equal subarray after deleting at most k elements from num. Okay, so you have to find longest possible equal subarray. Yes, and yeah, you can achieve this equal subarray after deleting some elements. And how many elements? At most k elements. Okay, and let's see the constants as well, or maybe let's look at the example here first. So here the array is given, and from the array you are checking if there are some possible equal subarrays. So one is like subarray of length 1, 3, 2, 3, and yeah, this is here you can delete 2 and 1, right? Yeah, let's see it this way. Here is the number array given, and here one possible subarray is just 1, second possible subarray is just 2, likewise, and then you can have subarray possible as 3, 2, 3, 1, 3. But wait, is it an equal subarray? No. But yeah, can you generate an equal subarray by deleting at most k elements? Yes, why not? Yeah, you have deleted 2 elements, and again you can delete up to 3 elements. So anyway, yeah, you can delete it and you can find this subarray. So here, how many elements are there in the equal subarray? 3 elements. 3 can be possible answer. But yeah, let's see if we can find any subarray which has greater length than 3. After taking 3, you have found out this. There are 3 elements possible. If you can take 1, you can also delete. Yeah, if you take this one, right? And here you can delete this in between elements and you can generate 1. But yeah, here also the length is 2 only, right? So 2 is anyway an equal subarray length, but this is not an answer. Why? Because 3 is already happened. So 3 will be answer, which is the maximum length of an equal subarray possible after deleting at most k elements, right? So yeah, trivially what you can do, you can just find out all the possible subarrays and you can check what is the majority element in that subarray, and you can delete all other elements, and you can see if after deleting all other elements, like are those deleted elements are like more than k. If that is there, if the number of deleted elements is even more than k, then that subarray is not possible. So just refrain from using it. So what you can do is, trivially, you can look at all the subarrays. This possible count of subarrays will be n into n plus n plus 1 divided by 2. Why? Because we have to find out length of all subaverage of length 1, that is n, n possible subarrays, then length of 2, n minus 1 subarrays, length of 3, n minus 2 subarrays. Likewise, like if you sum it up, all the possible subarrays will be n into n plus 1 by 2. And for all the possible subarrays, you have to find out majority elements in that, and then you have to find out the numbers which are going to be deleted, and then you can compare with k. So here the time complexity will be at least order of n into, yeah, that means order of n square, right? So let's see if we can use this algorithm, this trivial algorithm, to find out the answer. So you can see, friends, array length can be 10 to the power 5. Okay, n can be 10 to the power 5. Values can be that length, means values can also be up to 10 to the power 5. And then k will obviously be lesser than length. Okay, so is it possible to use 10 to n square time complexity if it is given, n is given as 10 to the 5? I think no, it will go to 10 over 10. So yeah, let's refrain from using it. Now let's go for some algorithm where we cannot go to 10 to n square. Sorry, we will not use any n square time complexity. So let's optimize it. So how we can optimize it? You can look at the question and think. But the first thing which comes to my mind is sliding window thing. So we can, instead of finding out all the subarrays, we can slide the windows, and optimally we can check if in that window it is possible to make a subarray of some length of some length by deleting at most k elements. So if you're considering this window, and in this window you are known that here 3 is in majority or 1 is in majority, so you can see that at how many elements you have to delete over here. So obviously here the length is overall 5 and the count is just 2, those are equal. So obviously you have to delete 5 minus 2, that is 3 elements. So 2 are equal and all others are just not equal to that element. So you have to delete all those, right? So for every window you have to do that. For every window you have to check the majority elements, and you have to and you will know that like the numbers which are going to be deleted is the window size minus the number of elements which have equal values. Okay, so the count of deleting numbers will be equal to window size minus equal element count. Okay, so yeah, let's see. This is how the count of deleting numbers will be found out for every windows, and for the after finding out this count, you have to compare with k. If this value is greater than k, then this window will not be considered, and we will also optimally check. We will also do some operations so that on the we will be getting next window optimally as optimal as possible, so that we are not encountering same values and again. And to make sliding window thing, as I am looking at this constraint, I am carefully looking at it, and I'm finding that the values will not exceed 10 to the power 5. So let's make use of values, right? Otherwise, you can deviate from here. You can look for cadence algorithm, you can look for using a stack, so many things. But no, we will not deviate. We will make use of the constants that are given, and we can check if it can work or not. Okay, so if it will not work, then we can find out other possible. But yeah, we will first look at, like, we will first try to utilize the constant that is given. So values will be up to 10 to the power 5 only. So we'll make use of values, and we will make, for each values we will try to, what we will do, for each values we will try to store indexes in some format. And okay, let's look for a graph for it, kind of diagram. Yeah, let's look into it. Yeah, so I'll be traversing from left to right, and since values are not very large, it's still 10 to the power 5 only, so we can maintain indexes for all values. So yeah, this is true. And once I'll start from index 0, so let's see for index 0 what we can do. Here the value is 1, so for 1, okay, let's write it here. For 1, what we'll do is we will keep index 0 here, and we can find out if the same value, that is 1, has occurred earlier or not. Since it has not occurred earlier, so we will not do anything, and we will see that the subarray length is 1 without deleting anything. So answer will be updated to 1. So here answer, let's look at in the last, but here the length of subarrays equals subarrays, what it is, it's 1. Okay, now let's come to index 1. Okay, and here the value is 3. Okay, since value is 3, what we will do is we will see if there is any indexes that is already been stored in value 3. Since it's none, value has been not been encountered earlier, so it's the first time. So we will just keep index 1, and we will see the length of equal subarray, and that is here also the length is 1. The only difference is here the value will be 3. Okay, and it's not just 1, let's make it 1 minus 0, because we are not deleting any element, so we are deleting 0 element, that's why it's 0. Okay, then let's come to the next index, and that is 2. Once coming to 2 index, the value is 2. So 2 also the same thing will happen. So let's copy paste here, just change the value, that is 2. Otherwise the length of equal subarray will be 2 only. Now let's come to 3. At index 3, so here we have given index. So once we are at index 3, the value is 3, and now I will check the indexes for value 3. So do you remember, For value 3, like I have encountered index 1. So at index 1, the value was there was also value as 3. So here also value is 3 for index 3 as well, and 1 it is already encountered. So if we will check at value 3, so obviously values will be made as the index in a particular data structure, and let's give you the clue. So data structure will have dq. We will have a dq of list of dq, and that will be indexed as per the values. So yeah, let's put all these things aside. Since we are at index 3, so we will look at if we have any indexes stored for value 3. So index is 3, value is also 3. Value is also 3. Okay. So we will not, like, let's put index aside. Let's look at value only. No focus or at index, just value. And now at value 3, what we have already done, we have one index, and that is 1. So do we have any other index as well? It has just one index, right? And now also take a look that it's not just about index, it's about first index. So we will look at the first index here. So first index that has already been stored is 1. So first index means the leftmost index. So leftmost index will, what we will do using leftmost index is, using leftmost index we can find out the length of subarray, right? So leftmost index is 1 and current index is 3. So what will be the length? Length will be 1 to 3. 1 is the first index and 3 is the current index. So how many element will there will be in the subarray if we are starting from this index 1? So it will just have a length of 3, right? Because you can just see here, you're just having these values, right? So here then the length of subarray is 3, and again, okay, let's make it something like this. Here's, okay, just this typo, correct, and there we have 2 index. Now I was stored 3 as well, and equal subarray will be 3 minus, and let's check how many elements we have to delete. The number of elements we have to delete is the length of subarray minus all equal subarrays. So how many equal subarrays? The indexes that are stored. So we are not just storing index, we are also like making count of it. So if there are 2 indexes stored, then there are 2 equal values, and those equal values are 3. So there are 2 indexes, so 2 values. So it will be 2 will be the length of equal subarray. That means we will be deleting 3 minus 2. Okay, so let's not put it minus 0, because we are just finding out the length of indexes, the count of indexes, right? So the count of indexes will just define the number of times that value has been occurred in the subarray. So the equal subarray length will be that only. And then to make that equal subarray, how many elements we have to delete? That thing is this. Deleting is 3 minus 2. And again, 3 minus 2, that means 1. And now don't forget this part. K is 3. That means you cannot delete more than 3. So deleting is just here, we are just deleting one element. Is it exceeding 3? No, we are just deleting one element that is obviously less than 3. So it's valid. So here the equal subarray length will be 2. So yeah, after 0 to 1, we have seen these three subarrays which had one elements only in the equal subarray. Now it's having 2. So 2 will be the answer as of now. But let's go to the next index, and the index is 4, right? And here value is 1. And since value is 1, so we'll look for value 1, and we will see if there is something in value 1. I think yes, we have value 0 in value 1, and we will just append the new index that we have already encountered for value 1. Now there are two indexes, but will be the length of subarray for equal subarray, that will be 2 because there are two indexes. But this is not enough. How many we will be deleting? So we will be deleting according to this. If we are going from here to here, how many elements are there? There are 1, 2, 3, 4, 5 elements are there. Okay, if you count all this, if we're including from here to here, that means 0 index to 4th index. Let's highlight this. Okay, so we are going from 0 index to 4 index, right? How many elements are coming? 5 elements are coming, but we are just concerned about equal values, that and those equal values are at index 0 and 4 only, that is, and value is equal to 1 obviously. So here how many we will be deleting? We will be deleting 5 minus 2. 5 is all the count, 2 is just equals. So here 3. Is 3 greater than k? No, it's also in valid. Why? Because we can delete up to k elements, that is 3. We can delete up to 3 elements. So this is valid. So here up to this also answer is 2 only. But yeah, let's proceed to the next index, that is 5. If we are at 5 index and we are making value as, what is the value at index 5? It's 3. Okay. Since the value is 3, we will check for value 3 what we have already been done. So we have two indexes in value 3. In that we will include one more index that we are currently encountering. So the new index list will be 1 and 3, and then the new index, that is 5. Now how many elements are there? 3 elements. So equal, how many equal elements there? So there are 3 elements whose indexes are 1, 3 and 5. Here it is 1, 3 and then this 5. And how many counts in the subarray without deleting? It's 3 and 3, 6. So without deleting, it's 6. After deleting, it will be 3 because we have 3 elements to keep which have equal values, and we have overall 6 elements. 6 minus 3, that is 3. We are deleting 3 elements. And is it valid? Yes, it is valid because we are just deleting 3 elements, and that is at max we can delete. So yeah, we are not exceeding 3. So this is good till now. And if you will take maximum of all the encountered equal subarray, so we have 3 is maximum, and that is answer as of now. As of now it is there. Let's proceed to the next index. Index is 6 now, and value is, what is the value at index 6? Oh, I think yeah, at index 6 the value is 1. And for 1, but we have already encountered, oh yeah, let's copy it from here. So this is what we have encountered already, but yeah, now encountering 6 as an index. So there are 3 values. So obviously equal subarray will have 3 value, but overall subarray without deleting will be how many it will be without deleting. So that will be, you can count it 1, 2, 3, 4, 5, 6, 7. So there are 7 values without deleting. So deleting will be 7 minus 3. Those are equals. Okay. So now it is 4. Yeah. So you can see you have to delete 4 items. Then you can get this subarray to be a valid subarray where one can be the equal values. To make one array an equal values for this much subarray, so this long subarray, you have to delete this, and this. So at index 1, 2, 5, and 3. Okay. So there are 4 elements you have to delete now. So to make this shorter, to not delete all these 4 elements, what you will do is you will exclude some value. So what you have to exclude? So remember, you are doing sliding window. So in sliding window, what we do? We exclude items from left side. As we proceed to the right, we exclude values from left. So we will exclude this 0. And after excluding 0, we will see if now we are valid. So exclude index 0. If I'm excluding index 0, then let's see if we are valid. So if we are excluding 0, then what are the indexes for value is equal to 1 is 4 and 6, and then equal subarray will be, yeah, is it true? No. 2 are the count of equal values, that so for index 4 and 6, right? So now we are not having this thing. I think anyhow we can somehow delete this part. Okay. Yeah. So we have deleted this thing. Okay. So in our window, we have these many elements. We are not having this, right? So and now since I have excluded index 0, so how many elements will be there without deleting? The elements without deleting will be this part. Yeah, this part. So the elements will be 4 to 6, right? Because I'll just including from this index only. So the leftmost index that will be there in this structure, in this DQ, right? So here I'm using DQ. So here the leftmost index that is given is the first element in the subarray. So first element is 4 and the last element is 6. How many elements without deleting? So there are 3 elements, and 3 minus, to find out the numbers to delete is 3 minus 2. Why? Because 2 are equal. Index 4 and 6 are equal as 1, 1. But index 5 is not equal. So yeah, 5 deleting element will be just 1. And is it less than k? Is it less than 3? Yes, it's less than 3. So this is valid. And the same thing we can do further and further, right? If we will have more and more elements, and we can obviously on each index we will increase the values in that particular we will increase the index, we will append the index for that particular value that we will encounter. But for that particular value, once we have appended the new index, then we also have to look if that DQ for that value is valid or not. If that is not valid, if that DQ is not valid for that value, we will try to remove some of the indexes from left or some of the values from the left. So here since like for example, for 1 1 and 1 we have removed value from the left, so leftmost we had this one, so we removed, and with the new list is this kind of new dq is this, and so for each of the values we are keeping dq, and we are we are obviously modifying dq like uh, as per need after encountering any value like from left to right. Okay, so let's look at the implementation now. So here you can see for each of the values I have created dq. So this is the list of dq, vector of dq, and for each values, so here these are the values. Okay, let's write a comment dq for each value. Okay, and here it's the value, and here I am just modifying dq by appending the index, the encountered index for that value. Okay, like this is dq for the given value, right? And I am appending I to it, and after appending I am checking if this size, okay, if this size is coming, if this size minus all the equal values is greater than k or not. If it's greater, then we have to remove values from front or from left, right? After making it, after making deletion count less than or equal to k, we come out of this loop and we check if we can update answer or not, and we can do this for all the indexes, right? Friends, I am keeping the solution link in the comment section, and if you have liked this explanation, please hit like button